So hello students, today we'll be going to discuss the building drawing, the part 2 elevation view. In the last class we have discussed about the plan view, as you know. So today is the elevation view portion we'll be going to discuss about, and I would like to give you the reminder that we'll be taking quizzes today as well. So listen very carefully, try to focus on the lectures and try to perceive all the features we are showing you, and just because based on these lectures we'll be taking you quiz, asking you quizzes, so you'll have to give the answer. The first one giving the correct answer will be given the bonus mark. So let's start with the elevation view of the building. So we can define this as the outside view of a building which you can see from any particular side. So by being a viewer, so if you are a viewer, if you are from the outside of the building in any side, if you look at the building and that view, you can look at that view will be called the elevation view. And if we talk about it geometrically, it will be the horizontal orthographic projection of the building onto the vertical plane. So by this time you know that what is orthographic projection of a building onto the vertical plane. So we'll be watching it into the vertical plane and along the horizontal projection. And another feature of this elevation view will be there will be no hatch. As you are watching towards the building from the outside view, and there is no cutting section through the object, that is the building, so you will not be able to see any hatches over there in the drawing. So this is one basic feature of elevation view of the building. So if I give an example of elevation view of a building, it will be like this. So let's say this might be a side view, any side view of any building. So this is to start with. If you see from any side, either side of the building, you'll be able to see this is the building we can expect. So in this building you can see where all these dimensions are orthographic, that is the dimension you can measure from the drawing. The 2D plane measurement will represent the actual dimension of the object or the components you can see in the building. So however, this is taken from an online source, so we will be moving further to see what is actual the elevation view of a building and how to draw this. So we are not going to discuss this drawing. This is just sort of example. There are some variations, there are some difference in conventions in different place, different location, different geographical condition. So we'll be focusing on our conventions mostly. So there will be a quiz for you. How many elevation view are possible for any conventional building? The options are given 2, 4, 6 and 8. So you can pause down the video. Okay, so I think by this time you have got the answer. The elevation view, there are 4 possible elevation views are possible for any conventional building, as you can look for either of the side. So we can say there will be 4 conventional sides of a building, as we have also learned from our object drawings. There might be front, back, rear or back, left, right view, etc. So these views will be called the elevation view. So there will be top and bottom view as well. Those are not called the elevation view. As you know, those 2 views are called the plan view. So elevation view of a building So it may be denoted as either, we can denote it as north view, east view, south view, west view. Also may be denoted as front, right, left, back, rear, as we have used it in our object drawings earlier in our course. But there are some pros and cons of these two conventions. So if I say the north view, west view, east view, okay, this seems very good. But if you think the building, the building is a rectangular one, and obviously each of the sides are parallel to each of the major directions, we can say north, east, west, these views. So then we can obviously say north, east, west will represent the appropriate thing for the building, as it will clearly indicate which direction we are watching. But what will happen if the building is tilted one? So if it is tilted one, if you see from the north side, not necessarily the faces are parallel to the north, south, east, west. So then in that case you will see something inclined, and that might not give the actual impression, or your observation will not be realistic as the purpose of our elevation view is. And in most of the cases, if we see in Bangladesh, we have shortage of land, so we don't want to use any of the land. We want to use all of the lands properly. So if we get any chance in any direction, we don't want to miss them. So we want to maximize the beauty, maximize the space. So most of the time you will see our buildings are not always directed parallel to these four directions. So in that case, front, left, back view, etc. view will be representing the actual visualization what we are asking for. But in the developed countries, or the countries where there are no shortages of land, they always tend to construct the building according to this guideline, that is, all the edges, faces of the building will be parallel to the major directions, north, east, west, etc. So there is a problem for tilted building, or if the building is not rectangular one, in that case it might create some problems. But still we can draw, if we want to draw those views, elevation views of those buildings from northeast, etc., then obviously we can draw. Okay, but if we say what is the problem of front, left, back, etc., these views, then question comes, which direction you should take as front direction, and based on this front you will be taking all the other views, right, left, back, or rear views. All views you will take on the basis of the front direction. So which one should you take as front? You might say, okay, the entrance, that will be called the front. Okay, there are some buildings, my friend, there are some buildings you can find. There are entrances, multiple entrances might be there, so you cannot define which one is the front side and which one is the back side. So in that case you will face problem. Which one will be the front? The front, by definition, we know there is no specific front for any object. In our orthographic view definition, projection definition, or oblique view, or all other views, isometric view definition. So we know from the isometric point of view that whatever the object is, we must show this is the front view. After drawing the isometric view, if we define this is the front view, then you take the reference of that view as front view and draw all other views as other views based on that front view perspective. But what will happen for this building? So you will have to define this is front. So there are some, so you know, this kind of some complexities might arise. So there are obviously advantages or disadvantages for both of these two conventions, so we might use any of this, although most of the time we might use north, east, west, these things, but in case of Bangladesh it will be better sometimes if we use left, right, front, back, etc. views. However, let's see the guideline. There you can see the guidelines for elevation view of the building. So in both case of section and elevation views, the guidelines are shown. Although we are not focusing today on the section, we will be discussing sections about section view of any building in the next class, hopefully, inshallah. But today we will be focusing on the elevation only. So you can see both of the section and elevations are guided to be drawn using 1:100 scale, and I again say these scales are mentioned on the basis of metric scale, just because in Bangladesh we generally use metric scales, millimeter, centimeter, meter, etc. But in our course we are focusing on the feet based scale, as you know. So however, there will be now a question for you. Get prepared for this quiz. So which portion of the building should be shown in an elevation view? So there are 4 options. Which portion you should include in your building? So by this time I think you have got your answer. The correct answer will be the above the ground level. The above the ground level you should draw the total view. You cannot draw only above the plinth level, neither you can draw including the foundation. So you will have to take the view above the ground level, existing ground level. So just because you will be, as from the definition we know, the viewer from the outside of the building, how he will see the building, that is called actually the elevation view. And obviously the projection should be horizontal, so you will be standing on the ground level. If you are outside the buildings, then obviously you should see the building from existing ground level, not below the foundation or nor the above the plinth level only. So it will be above the ground level. Okay. So there will be another quiz for you now on. Get prepared for that. There is another option for you to get the bonus mark. Which plan or plans of the following are required for drawing an elevation view? Choose all that apply. Okay, the options are ground floor plan, typical story plan, foundation plan, and roof plan. I think by this time you should get the answer. The answers will be option A, B, and D. You need ground floor plan, typical story plan, and obviously roof plan to draw the elevation view, just because without these 3 views you cannot know the actual properties, features of the building. So you should draw from the ground level to the tip of the building. That's why you should know the features of ground floor, features of typical story, features of roof as well. So these 3 will be required for us. So now the steps for drawing elevation, as usually you know, you should prepare your drawing sheet and you should use appropriate pencils. Then you should determine the building dimension. So building dimension from the plan view, you should identify, calculate the building dimension including the boundary wall. In the last class we might not have been discussed about the boundary wall. There must be a boundary wall which will denote the property line, and within that we'll be leaving some space. As you all know, we should leave some space for according to the guideline, and then we will be taking the total, will be constructing the building. So we'll have to include the boundary wall within the building. The total boundary wall dimension will be taken into consideration while drawing elevation view, just because we'll have to include those boundary walls as well, and then refer to the information of the each story features and highest tip of the building. That means we need the information of the story heights. Say for example, each story height, what will be the height of each story, you should know this, although you cannot understand it from the plan view. So you need to know that information. If not given, we conventionally use story height equals to 10 feet all the time, and some other considerations are there. If not given, obviously we'll have to assume reasonable values, but in practical life we'll obviously have to define those dimensions first. However, so then you will have to determine the available drawing space where you will have to draw this elevation view. So we can draw one elevation view in one paper, or sometime we can draw multiple 2 or 3 or 4 elevation view in one paper. That is also possible. So based on our requirement, if we want to draw 2 views on one drawing sheet, then we'll be dividing the available space into 2 and then determine the appropriate scale to draw this within the paper. So for example, so you can also draw 4 drawings at a time. So then you know how to choose appropriate scale from the last class. And if there are any direction by the code, as you have seen 1:100 given, so if it is restricted, then you must follow that convention. Okay, then omit any hidden lines. As you all know that from our orthographic perspective, in the object drawing we have seen there must be some hidden lines which you cannot see from the outside, but that lies within the object and on the other side of the object. Those lines should be shown using hidden lines. But in building drawing, as this is a complex one, so we might omit some of the hidden lines if our purpose is being hampered. Say for example, if we want to show all the components lying behind this particular view, the elevation view, and we see that these hidden lines are obstructing and making it very much complex to understand what is the actual outside view is, then you can omit those hidden lines if necessary. And we must include some lines obviously hidden if it is necessary to visualize. Say for example, we might include the slabs. We cannot see slabs from outside, but we cannot identify the stories properly or accurately if we don't know where the actual slab is. So we can give the slabs using hidden line if we wish. We'll be watching while drawing it. So in that case, we'll be see how to omit some hidden lines, or how to place or take some hidden lines, include some hidden lines where it is necessary to visualize. And finally, after the drawing, as you know, you will have to give proper dimension or other necessary information for there. So let's not make any further delay, so let's get into the drawing. So we'll be starting with our previous plan, and today we'll be drawing the elevation view of that particular plan. So now we'll be watching first up to the ground floor portion elevation drawing, how to draw. As you know, 4 elevation drawings are possible, so we'll be watching we'll be following the convention of north, west, east. Okay, this convention, these 4 drawings, north, south, east, west, these 4 sides views will be drawing for the particular plan. So let's get started with that. Okay, this is the typical plan we have already seen in the last class. So today north direction is given there, and this red line, have you noticed, this is the property line. We can say the property line or the boundary line of the building, from where we have kept some offset for the building, the original structure. According to the guideline of the code, we have to keep some distance, and this distance for this side, let be 3 feet 4 inch as it is given. So we can also assume the same dimension here, 3 feet 4 inch. And for this direction, 3 feet 4 inch seems quite impossible, just because the veranda alone, the dimension is given 3 feet, and if you add some offsets there, and if you see there, it is impossible. Or being 3 feet 4 inch, rather we can assume this as 4 feet or 4 feet 6 inch will be fair enough. The same thing goes for this direction as well. There are verandas over there, balconies, so we could take this as 4 feet or 4 feet 6 inch. So unfortunately we don't have the ground plan and the roof plan with us. So just using the typical plan, we'll have to draw the elevation views. We'll try to assume what is actually the objects over the ground floor and roof accordingly, just as we have the elevation views with us, and following those elevation, we'll try to draw the elevation view ourselves. So we'll be assuming the objects by visualizing those elevations. So before getting into the elevation, you know what to do. You'll have to calculate the dimension first, the total dimension, adding the offsets of boundary line, property line, and also you should know the total story height of the building, and the tip of the building height you should know, so that you can merge it into the available space of your drawing. After that, one thing you'll have to assume, this property line, after construction of the building, no building will be left over. So there will be the boundary wall over this property line. There will be a boundary wall throughout the building, encompassing the building. So this boundary line will be the object of our elevation. So if we give focus on the elevation views, we'll be able to see. So let's go to the elevation view to identify this. First of all, if we go to the west elevation view, as you can see, this is the west elevation view. How to start with? In every elevation view, we'll be starting with a straight line, the horizontal line, which will be indicating the existing ground level. As you can see, the existing ground level. So this indicates the existing ground level, and after that 3 feet will keep offset from there. That will indicate the plinth level, and this will be called the ground floor above this. And you cannot see anything, just because of what? This is the boundary wall, the solid boundary wall throughout the building, which is hiding something, the ground floor being exposed to the outside. So this is the solid boundary wall, and as we have discussed, we can take this distance, the exterior edge of the building, to the boundary line. So obviously the boundary wall will be constructed inside. The thickness of the boundary wall will be inside, not the outside of the property line, this point being the property line, and there will be thickness of the wall inside the building, not outside. So this dimension will be, as we have said, either 4 feet or 4 feet 6 inch will be fair enough. And another thing, as we have said, this plinth level, so this will be the plinth level for us. So we'll be drawing a plinth level, and as we don't have the plan of the ground floor is there, So we can assume this boundary wall to be 10 feet from the existing ground level, which indicates that will be 7 feet above from the plinth level, this plinth level. So we can assume this will be 7 feet above the plinth level, the boundary wall, and this will be the remaining 3 feet of this 10 feet if we subtract this 7 feet. However, so another thing, if you could notice that this is the start of the plinth level, but up to which dimension this 10 feet indicates. So if we focus on this, if we focus further on this dimension is actually representing this point, this line, not the line below this. If you can visualize, the same thing goes for the next floor as well. So this means the distance between the floor height to the floor height, not the ceiling. So for first floor, for the ground floor, this portion, this surface is your ceiling, and for first floor, this portion, upper portion, is the floor, and this is nothing but the slab thickness. So there is some thickness, say for example that will be 6-inch slab. So even if you calculate the distance from the floor in your room up to the ceiling, you'll find that is not 10 feet actually. Just because of what? Just because there is a slab over your ceiling, and it adds up this distance to 10 feet. So that's why the 10 feet will be the float to float distance every time. Over. So let's move to the next elevation view, that will be the south elevation. So this is the south elevation. Similarly, this is the boundary wall. If we say this time this will be 3 feet 4 inch south elevation. You can again see south elevation. Okay, before getting into this, we need to talk about the direction, which direction we are denoting which elevation. So this is the south side of the building. So if you stand over there and watch from there, so this will be your south, this will be the south view of the building. It indicates you are actually placing to the south of the building, not you are watching directing to the south direction. Rather you are directing towards north, but you are on the south side of the building. And same thing goes for there as well, and just because of that it will be called north view, just because you are standing on the north side of the building. In this case this will be called the east view, just because you are standing on the east side and looking towards the west. And this will be the west view in similar manner. So this was the west elevation we discussed previously, and now we are discussing about the south view. This is the south view. So from this you can see this 3 feet 4 inch and this 3 feet 4 inch, and that's why we have placed 3 feet 4 inch, and this will be 3 feet 4 inch. However, now come look there, this is the boundary wall. This boundary wall has gone up to this point, this portion. This is the solid boundary wall. Okay, and this portion is the boundary wall, but there is an opening over there. There is no boundary wall over there, so that's why we can watch over into the building. So this portion is actually integrated with this building, not this boundary wall. So what is this? If we take a look over there, so this is actually the closely spaced lines indicates the ramp, and this is a big sliding door. So any vehicle entering there will be using ramp and going through this whenever the gate is opened up, sliding. So if you can see this red portion over there, this indicates the total opening of the gate. Just because of this boundary of the boundary wall obstruction, due to this obstruction you cannot see what is over there. So if this wall was not there, we could see this gate. If we slided it towards this direction, then it can accommodate up to this one, or there will be also some opening for the pedestrian to enter with some steps of stair, so that pedestrian could enter into the building as well. So but for the opening, the vehicle should enter the building through this opening, so there is no boundary wall or obstruction over there. However, again, as we don't have enough information over there, as we don't have the ground floor plan, so we cannot force you to draw something over there using hidden lines. So better not to draw anything, but I think you can understand what is going on. However, and this is good just because you can see wheels sliding door. However, now focus on this point. Can you see some vertical lines? This is actually representing the grill. So as we have said, these portions are the solid portions of the boundary wall. There are some openings using grills, just because of what? There might be gardens over there, so enhance the aesthetical view or the beautification of the project. They might include some grills over there for gardening purpose. So one example of boundary wall garden might be this one. So you can see sometimes there are boundary walls like this one, these portions you see, and some other portions are solids, greenly solid, not the some portions will be left over for the gardening purpose. However, the south portion, so these portions will be left for the gardening, that's why we show grill. And this is again the solid portions. The door, from this figure we can understand this door cannot be slided into this direction, or it may be, but rational thing we can understand this door will not be going towards this direction. It cannot accommodate enough space to open this up. That's why. However, so same thing as we have discussed, that this will be 3 feet and the 10 feet. So the boundary wall, we can say 10 feet from the ground level or 7 feet from the plinth level. So this is actually the plinth level. Okay, the east direction. So when we come to the east, let's see the typical plan. Let's see the typical plan of east side. East, this was the east view. So from this point of view, we can say we'll be watching this boundary and this one. So we can take this as 4 feet, 4 feet. So this one we can take it as 4 feet. Also this side as well, or it may vary in dimension. As we don't have enough data, we cannot say. And this is the boundary wall, as we know, and as we cannot show any, we can show only the hidden lines like this, nothing more than that. After that, go to the north direction, north elevation. So this will be the north elevation. So if it is the north elevation, we have something to say. Let's go to the typical floor plan. One thing, can you notice that this portion, this is below the first floor? What is that? All other things you can draw similar pattern like this. So don't include this portion as we don't have data. So what is this one? And we can see this on every floor of the building, and that is something unusual than other openings like windows or doors of the building. All the openings, windows, doors will be in the same height, up to 7 feet from the ground. But what about this? So this is, if this is the story height from this one to this one, this will be the 7 feet story height. Also this one will be 7 feet story height. But what is this extended portion? Why this one is elevated like this? So if we go to the typical plan for north elevation, we can understand what is going on there. North view. So let's see what is the north view here. So north view over there, this is stair actually the stair. This open stair, this opening is something elevated, but why not as the same elevation of other openings? Let's try to find out the answer from the section of stair. We'll be discussing section in the next class. So if you see, this is a typical floor, ground floor, ground. This is a typical floor, this is ground floor. So for any floor, this from this floor height we start any opening, say doors like this or this. But what happens for the staircase window? This is a staircase window. We don't have any staircase window in the bottom story in this level. We need to place any staircase window only after we go up to the mid height of the stair, and then we can see the window. And this window obviously not starting from the same elevation at the ground floor door, windows, or other typical story ground window door do. Just because of that, this is something elevated, whereas the window or door of the typical story is stopped up to there, starting from this floor level, but the stair window will be starting from there up to this portion. That's why every time this is somewhat elevated, although this is not actually representing the actual section view of our drawing. Just to explain, our drawing will give a opening of window staircase up to this level. So this highest point of the window will be this point actually in our case. So however, so from this we can get idea, and let's go to the north elevation again. So this is the stair window, we can see from there, this one stair window in each story, that is something elevated from other openings. So this is stair. And what about this, the red portion? As you can see, the red portion. What is the red portion? For every opening, window or door, you know that there are not door, for every windows there are sunshades. So this is actually the sunshade. So we need to draw sunshades. So this thickness of the sunshades will be not more than 6 inch. Better if it is 4 inch. However, so, and there will be some extension beyond the window for this sunshade. Say this be not more than 1 inch, better be 0.5 inch each. And what will be the dimension of the window? So you can take any reasonable dimension, as we haven't defined any particular dimension for this window, veranda, sliding doors. So you can use any reasonable values. Say might be 4 feet by 4.5 feet, whatever you wish, but make sure you have taken any reasonable value for this window dimension. And there will be a sliding 2 compartment of the window. However, by this time we have completed drawing all the elevations up to ground floor, up to the ground floor. Now we can start first floor after that.